Hello, welcome to Lesson 8. In Lesson 8 we will speak about wireless networks. And as you know by now, in these lessons we follow the Cisco certification guide. So I assume that you've already studied the chapters about wireless networks, which are chapters 26 through 29. And they discuss the fundamentals of wireless networks, wireless network architectures, and securing and building wireless networks. So in these lessons I will not repeat the material in these chapters as you've already studied them, but we will do a quick review by going through some questions, and then we will jump into the practical side of things by doing a lab, and in the lab we will build a wireless network from scratch using a Cisco wireless LAN controller, a Cisco access point, and a Cisco switch. First review questions from the RSSI. Which transmission level is considered poor? And the answer is A, minus 60 to minus 70 dBm. It's very usable, but it's considered a poor signal. Where answer B is a very good signal, D is a loud signal. And too loud can also be problematic. And C I think is impossible, maybe unless you're sitting on the very tip of the antenna. But you will not see that in practice. Next question, which of the 2.4 GHz channels do not overlap? And the answer that we're looking for is channels 1, 6 and 11. Where this is true for most countries and especially for the US. In some countries there can be other solutions, like for instance in Japan it is legal to use channel 14 and you could create 4 non-overlapping channels by going 1, 5, 9 and 14. But in the case of the exam, the answer that you're looking for is 1, 6 and 11. Which of the acronyms best describes multiple wireless access points broadcasting a single SSID? And the answer is A, an extended service set. A basic service set is the area covered by a single access point. So in this case we're looking for answer A. Next question, client traffic needs to transition from one access point to another. Which of the following helps to maintain the same session? The answer that we're looking for here is answer D, the split MAC architecture allows for clients to roam between access points because the work is divided between the access points and the wireless LAN controller, and the sessions are maintained in the controller. What is another term for using a pre-shared key for authentication and security? The correct answer here is answer C, personal. The full name for the standard is WPA2 personal or WPA3 personal. Or if you have an older access point, WPA personal. But personal, the personal keyword hints to the use of a pre-shared key, because there's also a thing like WPA2 enterprise where you use external authentication sources. So answer C is the correct answer here. Rank the Wi-Fi security solution from best to worst. So the best in this case is WPA3 enterprise, followed by WPA2 Enterprise, WPA2 Personal, WPA, Web, and last, Open Authentication. In practice I would not use Web or WPA because they are older standards and in these days they are quite easily hacked. Whereas there could be a use case for open authentication, maybe on a guest network, but I would not use Web or WPA. So which feature of the wireless LAN controller allows clients to move from AP to AP, also called roaming? And that's answer A, the mobility RF group name, because all the access points in a mobility group, they are the access points that you can roam between as a client. Which of the following will require a user to authenticate to the wireless network with domain credentials? It's a bit of a tricky question. Choose the best answer here. So that will be answer D. Because when you use radius.1x combination, you can use plugins to radius that talk to maybe your Active Directory controller. So you can log in with your Active Directory credentials. If you had any problems with the review questions, then I would consider going through the chapters again. So let's go to our lab. In our lab, we will configure a wireless network using a Cisco wireless LAN controller, a Cisco access point and a switch. And in this case, we have bought the wireless LAN controller and the access point secondhand, maybe for our lab. So we will have to do a reset to factory default. Then we will upgrade to the latest recommended release of the software. And for this lab, we will pretend that my version 8.5 something is the latest release, because that's the highest release that I can legally use. It came with my access point. I don't have a support contract to really download the latest recommended version. So we will pretend that 8.5 is the latest recommended version, and we will upgrade to that version just to see how the upgrade process works. Then we will do a base configuration of the wireless LAN controller, and we will only use one interface in this lab. There's multiple interfaces on the wireless LAN controller, but we will keep it simple for the lab. We will also factory default the access point, and then have the access point join the wireless LAN controller. And we will set up an additional Wi-Fi network, because when you factory reset the wireless LAN controller and then go through the startup wizard, a wireless network will be created for you. And I would also like to give you the feel of making a wireless network by hand from scratch. So that's part 6 of our lab. And we will use WPA2 with pre-shared keys for all the wireless networks, because I don't have a radius server or other external authentication source. So that's our lab. Let's get into it. So here we are in the lab. I have connected my serial cable to the console port of the wireless LAN controller, allowed it to boot, and as you can see, we now get the option to choose recover config to reset the wireless LAN controller to factory defaults. And this is by far the easiest method to do a factory default reset. So as you can see, the controller is now in the process of resetting to the factory defaults, after which it will reboot, which will take a while. So in a moment I will pause the video, but I will take this opportunity to explain what we will see after the reboot, because we will get a choice between two options, one of which is the auto install, which is a function that allows the controller to get a pre-made configuration file that sits on a TFTP server for the controller to download and get its configuration from. As we do not have a TFTP server in the lab, we will not choose that option. So we will cancel the auto install, and then we will be dropped into a menu where we can manually configure some settings for the controller. So I will now pause the video, we will wait for the controller to completely boot, and then we will go through this process. And there we are, the controller has rebooted. We will now cancel the auto install and configure the controller manually. So the system name, this is our lab controller. We will use the username admin. This password obviously doesn't need to be as complex in a lab environment, but we are required to make it a little bit strongish, so we need to use capitals, numbers, and special characters. So let's use lab with a capital L, 1, 2, 3, exclamation mark. And in real life you will hopefully choose a stronger password. Link aggregation. This allows us to bundle multiple interfaces into one logical interface, which is very handy if you have the requirement for a higher throughput than a single interface can provide. As we discussed before in our lab, we will keep it simple and we will just use one link. So I will say no here. We will not use a VLAN tag for the management interface, and we will use interface number 1. And our router is also our DHCP server. So we will create a mobility group called CCNA. First wireless network that we create is also called CCNA, and actually that wireless network will be going out of the controller untagged. It basically shares the management interface as we configure it now. I do not have a radio server in the lab. I am in the Netherlands. And here I would like to disable the 2.4 gigahertz radio, because I do not want to interfere with the production 2.4 gigahertz networks that we have in our office. I do have enough space in the 5 gigahertz band to not cause interference, so we will enable that. And I do not want to configure NTP or the system time at this point. We will do that later. So now again, the controller will take this configuration and reboot with it. So I will pause the video again and we will continue when it's booted. So now that we are ready with the controller, at least for now, it is time to set up our switch. We need our switch to provide connectivity between the controller and the access point, but also the switch sits between our router and the access point and the controller. It is configured as a layer 3 switch, as you will see. So let's take a look at the switch configuration first. We will use this base configuration. We will have 2 VLANs on the side facing the router. We have VLAN 188, and on the side facing the wireless LAN controller and the access point we will have VLAN 199, which is also our management VLAN. We will create a DHCP service on the switch. Now at this point in your CCNA studies you will recognize and understand this configuration. There is, however, one thing I would like to expand upon, and that's the configuration of Gigabit Ethernet 102. It's the connection to our wireless LAN controller. And what I did there, even though we are only using VLAN 199 on the wireless LAN controller at this time, and that means we could have used an access port, I did configure this port as a trunk. So that allows us to add VLANs later on, because further on in the lab we will use VLAN 200 for our second wireless network, and if we would add more wireless networks that connect to other VLANs, we could do that. We could simply say switchport trunk allowed VLAN add and then use the number of the new VLAN to add it to the trunk, and that way we don't have to reconfigure the port later. So that's why I didn't use it as an access port at this point, but I prepared it to be a trunk. And since our first wireless network, which uses VLAN 199, doesn't use VLAN tagging, we used VLAN 199 as the native VLAN, which means that it's untagged on this interface. So let's put this configuration in the switch. And there we are. So as you see, I kept the interface facing the access point in a down state, because as soon as I no-shut that interface, the access point will power up, and I don't want it to just yet, because now that the switch is configured, I would like to move to the access point and show you how to give the access point a factory default reset in order for it to have a clean configuration and then join our controller. Resetting the access point with one hand is a little difficult, so I went and did a no shutdown on the interface, and I now have the Ethernet cable in my hand, which I will plug into the access point any moment. I will show a picture of the access point. I will make a slide for that, so you can see what it looks like and understand what I'm about to do. Because what I will do, I will press down on the mode button on the access point, and at the same time I will put in the network cable, and I will keep the mode button pressed, and you will now see some boot messages on our screen, and at some point the access point will say that the mode button is pressed and waiting for the button to be released. And that's actually the point where we will release the button, and then the reset to factory default will be complete for the access point. It takes a little while, so I will pause the video in the meantime. Oh, no, there we are already. Sometimes it's quicker than expected. So I will now release the mode button. And as you see, I have pressed it for 33 seconds, which is long enough. I think you need to press it for like 20 seconds to do a reset to factory default. And now at this point, the access point will boot up and then look for a wireless LAN controller to join. And this process does take a while, so I will pause the video. Okay, so the access point has booted. Sometimes it can happen that it doesn't boot automatically and it drops you into a AP prompt. So that prompt literally says the letters AP and a colon. And then you just have to type the boot command there. Then the access point will boot. And as you can see, now that it has booted, it finds the wireless LAN controller, but it does not join it. This line is interesting. It says here, certificate verified failed. So what's actually the case here is that this is an older access point that I use for lab purposes only. And it has a burnt in certificate from Cisco that has actually expired. So this is also the reason why earlier in this lab I did not set the time and date for the controller, because what we will now do is we will go to the controller, to the GUI. We will configure a time in the past where this certificate was valid. Then the access point will actually join the controller, and after that it will get updated by the controller and the certificate will get updated, and we can set the time to the correct time of today, and it will no longer be an issue. But sometimes with older access points this can happen. I would expect when you buy new access points from Cisco you will not have this problem and you will not see this. But if in real life you sometimes buy a second-hand access point, or you repurpose an older access point that you have lying around, you may get into this situation. So yeah, it's good that you've seen it here and know what to do. So I will now pause the recording and swap to the LAN controller again. So here we are at the GUI of the wireless LAN controller. We will log in with the username and password that we configured. It was lab with a capital L 123 exclamation mark. I don't want to remind that or remember that. Yeah, and here we will basically always go to the advanced tab, because that's where all the configuration that we are going to do will happen. As you can see, the access point is not registered. See, under wireless and all APs there is nothing. And our system time is the year 2000. So when we set it to today, the burned in certificate will not be valid anymore. And in 2000 it was not yet valid. So we will set the clock to somewhere around 2016, and then that should be sufficient to actually get the access point to accept the certificate from the controller and join it. Let's say November 2016, the rest is not that important. And then we should of course log in again, because our login session was not valid for 16 years. There. Okay, so now the time is correct from the point of view from the burned in certificate, and we will jump back to the access point to see if it wants to join the controller now. Okay, so we are back at the access point, and it has rebooted and successfully joined the wireless LAN controller. We can see that here. Joined the controller lab WLC. So setting back the clock worked, and what we can now do is set the clock to today, and then actually this access point will have received a new certificate already, a new configuration, and it will stay registered with the wireless LAN controller. How we will do that is by going back to commands, set time, and we will set today's time. It is November 11th here. There we are. That's the correct time. We need to log in again. So the time is set correctly. And now we will wait to see if the access point deregisters from the controller and then re-registers. Okay, so the next thing is to see if we can actually connect to our new wireless network. And at the moment that's not the case. And why is that? It's because when you pre-configure a wireless network like this by using the startup wizard, as we did, you will basically get .1x authentication. We can see that here under the security tab, and here you see it. So the authentication key management is done by .1x, and as I explained earlier, I don't have a .1x server in my lab. So what we can do here is create a pre-shared key. I will make it all capitals, or all lowercase actually, it's easier. Cisco CCNA. And then we need to save the configuration. And after you've pressed save configuration, you need to wait. In the background, the wireless LAN controller is saving the configuration. But if you now click through another menu, it will actually stop saving the configuration. It will not save the configuration, and your changes will be lost at the next reboot. So that's a bit tricky. It's well, I won't call it a bug, but it's the way the wireless LAN controller works. To get a feel for how long saving the configuration takes, we can do it here on the CLI. it's saved. So as you can see, it takes quite a while. And whenever you save the configuration in the GUI, please wait for a confirmation to pop up that the configuration has been saved before you do anything else on the controller, or else you will lose your changes. Yeah, and with that we have a working wireless network. So that means that we have completed the 5 first steps of our lab successfully. And I promised you that we would also do a upgrade, which we haven't done so far. So let's get into that now. We would like to upgrade our wireless LAN controller to our pretended latest release, which in this case is 8.5.103. And as you can see, I'm already running that version. But it's absolutely fine to reinstall that version on top of the running 8.5.103 version. So at least we can take a look at the upgrade process and get familiar with that. And to do the upgrade, we need to go to commands. And we want to download a file. So this is from the perspective of the wireless LAN controller. So download is from you to the controller, and upload is from the controller to you. So you're basically pretending to be the controller, and then it makes sense. So let's choose the upgrade file. And our file is the 8.5.103.0. We want to use this AES file to upgrade our wireless LAN controller. And now that we've selected the file, we click download, and the process of downloading the new software and installing it will start. And I actually paused the recording because this process takes some time, but I would like to explain that this is basically all there's to it. So we've selected the file, we click download, and the rest is an automatic process. So after the download is complete, the wireless LAN controller will start with the installation of the code, and then reboot into the new software version. And that's really all there's to it. So yeah, it's quite a straightforward process to upgrade the wireless LAN controller. You can also do it by the CLI, which is a bit more involved, but beyond the scope of this lesson. So one task remains for our lab, and that is to create a wireless network manually. So let's do that. First thing to do is to create an interface, because each wireless network is connected to an interface. So let's give it the same name as the new wireless network that we're going to create. And here we can specify a VLAN ID. So the previous wireless network that was created for us by the wizzard had no VLAN ID, so it was untagged, using the native VLAN basically. And this one, on the switch, I prepared VLAN 200 for the new network. We need to give the controller an IP address in this new VLAN 200. And we will point to the same DHCP server that we use for the other network. That should be enough. Of course, yeah. we do need to specify a port on which this VLAN will be tagged, and we will put it on the same port that we used for the other network, so port 1. So there we are. Now let's create a new wireless network and connect it to this new interface. So this is where we connect the new wireless network to the newly created interface. And of course we need to secure it. By default it will use .1x, which we will do not. We will use a pre-shared key. And we will use the same pre-shared key that we used for the other network. So that was Cisco CCNA, all lowercase. And that's it. Now we have the new network created. It is still disabled. So I guess we missed that tick box. There we are. We should enable the new network. And now I would like to actually show you that it's working and see if we can connect to this newly created network. Let's go to clients. And here you will see that I have one iPhone connected to the CCNA wireless network and another iPhone connected to the CCNA2 network that we just created. And it's gotten the IP address 2.11 from the DHCP server. So yeah, we created a working wireless network. We created it manually, not by using the startup wizard. So this completes our lab for today. But I will not leave you without keeping my promise. I promised to show a picture of the access point and explain what I did when I gave it a factory default reset. So what you see here on the screen is 2602i that I use in my lab. The image is a bit fuzzy, but I think it's clear enough to get the idea. Here you see the black mode button, the console port, and the Ethernet port, which actually also receives power over Ethernet. So we don't need the power plug here. We can just use power over Ethernet. And what I did when I gave it a factory default reset is press and hold the mode button with the console cable connected, so I could monitor this process on the console. Then I plugged in the Ethernet cable, which provides power over Ethernet, so the access point was going to boot. And as soon as we saw, we've seen this in the lab, so as soon as we saw the message that the mode button is pressed, waiting for it to be released, we released the mode button and the access point resetted itself to factory default, after which it could connect to the wireless LAN controller. So let's recap what we did today. You studied chapter 26 through 29 about wireless networks, then we practiced with some questions and answers, and we built our lab. Now, normally I teach these lessons in a classroom environment where the students have the benefit of interacting with me for any questions or comments. And here, in the case of this video, please feel free to leave your comments below, and I will try to respond to them as best as I can. Thank you for watching.